Hey guys, all right here. I wasn't on the first video, didn't want it to be too distracting. Anyways, I'm going to start this problem. It's a little bit different, and you can tell that it's a little bit different. It says, what do you notice or wonder about this graph? Automatically, if I look at it, I say, hey guys, like it doesn't look like things are connected. Maybe things are stepping up a little bit. Parts of it are flat. What does that open circle mean? Man, there's a lot of things that are going on in this case. And those would be some things that I would definitely notice right away. So let's keep on going with this. It says the relationship between postage rate and the weight of a letter can be defined by a piecewise function. The graph shows that 2018 postage rates for using regular surface to mail a letter. And we're looking at the relationship between a postage rate and the weight of a letter. Okay, and what it's saying is it's just saying, okay, the dollar, if it's between $0 and $1, you'll notice it's 50 cents. And then between $1 and $2, it means that it is $2. So let's go ahead and just check out a couple problems right off of this. Okay, and once again, you'll need your PearDeck open just to make sure it says, understand what it is. It says, what is the price of a letter that has the following weight? So let's say I want to go to 1 ounce. Okay, and automatically, let me change the color up a little bit. I'm going to go to blue this time. Okay, and it says, well, what is the price for 1 ounce? Well, I go down to the x-axis. You can see that that is the domain down here, is those ounces. Okay, and it says 1 ounce. Well, if I look at 1 ounce, I'm going to go to right there. And I'm going to say, well, okay, it's got to be either 1 or something below that 0.75, maybe like 60 cents or something like that. Not 100% sure right now. But I would say, well, notice that this is an open circle and this is a closed circle. Well, the difference, this just means undefined. So there's our undefined information, and this means defined. And the defined section is where the answer is at, essentially. Okay, so if I was to say, well, 1 ounce, I'm going to say, well, 1 ounce, it must be 50 cents. Okay, so it's got to be 50 cents. I know I'm scrolling in on there. It's probably a little bit freaky right now. Okay, and then if I keep going with that information, I'm going to say, okay, well, 1.1 ounces. Well, tricky part here is when I say, well, 1.1 ounces, that looks like, well, 1.1 looks somewhere right around there. Okay, and if I go to 1.1 and I scroll up there, that means that that y value that's associated with this x value, well, that guy's somewhere below 0.75. How about we say, I don't know, 0.66 or something, 66 cents. It's not quite in the middle. So let's go with 66 cents. We'll call that 66 cents. Okay, so maybe 0.66 cents or 66 cents there. And then it says, well, 0.9. Well, 0.9 ounces. Okay, well, I know 0.9 is below 1. Okay, so let's go ahead and change that color up. I say, well, 0.9 is below 1. Which is approximately right there, right? And I'm going to say, okay, well, 0.9, it's got to be somewhere right around there. It looks like it's going to be, well, 50 cents again. So, okay, well, 50 cents again, okay? Then we go to number 2, and it says, a letter costs 92 cents to mail. How much did the letter weigh? 92 cents, 92 cents. Well, I know dollars are over here. Dollars are over here. There's our range values. Okay, and I say, okay, well, dollars are over there, and I'm going to say, well, let's go here. 92 cents, there's the 50 cents mark, there's the 66 cents mark, and there's a dollar, so it must be right here. So if it is, a letter costs 92 cents, how much did the letter weigh? Well, it could weigh a bunch of different costs. Well, at 92 cents, we start that here, and it goes to there, right? So I'm going to say, well, it starts at 2 and then it goes to 3. So let's say, okay, well, it starts at 2 and it goes to 3. And those are our x values. I'm just going to use x for now because I haven't defined a variable. I'm going to say, okay, well, the x has got to be between 2 and 3. But check it out. It's undefined again right there. It's an open circle. That means that can't be an answer. So I'm going to say, well, it can't be 2. But it can be greater than 2. So I'm going to say, well, it can't be 2, but it can be greater than 2. Okay. And then I come over here and I say, well, at 3, it is defined. So I'm going to say, well, it can be 3. It can be equal to 3, but it can also be less than 3. And on the last video, I showed you another way of writing that domain. And so I'm going to write it in what we call interval notation as well. I'm going to say, okay, well, it could be 2, it could be 3, but notice what I do. I'm going to put a bracket right there, and then I'm going to use a parenthesis right there. This is undefined. This is undefined right here, and this is defined right there. And that's another way I can write that domain. Okay, let's go ahead and see what's going on just a little bit further down the road. Okay, let's go to clear. And it says, how did you know what to pay for a letter that weighs 1 ounce, given that there are 2 output values that corresponded to the input value of number 1? What I want you to do is go back in the video, and I want you to answer this question on your own based off of what we looked at right there earlier in the video. Okay, and then let's go ahead and keep moving. Okay, I'm going to grab that, move it over to the side. Okay, and it says just a little bit more. It says Kieran and May wrote some rules to represent the postage function, but each of them made some errors. Okay, so let's look for a few of those errors. Okay. So it looks like we've got some pretty good work going on here. I'm looking at 0.5, I'm looking at 0.71, 0.92, and 1.13. And they both actually have the exact same value. So we're in good shape there. I believe that. I've got, if I just look at it, it looks like, and I'll write it on there, why not? 0.5, 0.71. Apparently it's not 0.66, but it was a good approximation. 0.92 and $1.13. And all of them fall in that. And in that category right now. And now we just got to look at some errors that are in there. So it says, let me change the color just a little bit. It says between 0 and 1. Well, if I look right here between 0 and 1, 0 is here, 1 is right there. But once again, we come into this idea that that is an undefined answer. And this is, so let me write that down. This is undefined, okay? And this right here is defined, okay? Well, if it's undefined, it cannot be equal to it, okay? But if it is defined, that means it can be equal to it. So what I'm gonna look at is I would say, well, at 0, it can't be equal to 0 in this case. So I'm gonna change this. I'm gonna say 0 is less than W, okay? And then it can be equal to 1. So I'm gonna say to 1. In fact, if I look at it and I continue it and I look at 1, 2, 3, and 3.5, 1, 2, 3, and 3.5, all of those should be equal to. So these are all correct on this side. So I'm gonna go ahead and add those 1, 2, 3, and 3.5. That's good stuff right there, okay? And then when I come over here, I'm gonna say, well, what about these? Like, we've got the same numbers, 0, 1, 2, 3, 0, 1, 2, 3. And I'm gonna say, okay, well, let's go with that. Let's go 0, 1, 2, 3. None of those are defined. So in this case, it looks like this section is correct because none of them are defined whatsoever. So now what I need to do is I just need to erase these little equal marks that are in there. So the last thing I want to talk about before I move on and go and leave y'all to finish out this on your own is I want to just talk about the domain, how I write the domain and the range. Okay, so the first thing that I want to acknowledge is the domain. So let's go ahead and do domain. Okay, so the first thing is that the domain starts at 0. So I'm going to start and say, hey, it does start at 0. It's just undefined. And that means it can be greater than, but it can't be equal to. Undefined means not equal to. Okay. And then I just follow it out. I say, well, as I follow this graph, this fills in that hole. So this is the answer that fills in that hole essentially for the X. And then we just keep working our way across. This kind of fills in that hole, making it, you know, kind of in a way connect, but there's an answer at 2. And then at 3, there's an answer. It's just right there. And then it ends at 3.5. So I'm going to say, well, 0 is between, I'm going to use W's now because we've defined it as a W here. 0 is between W, and I'm going to say less than or equal to 3.5. You can actually read it right out of here and there as they connect to each other. Kind of hint there. So 0 to 3.5, I'm going to write it in interval notation. So not included 0, comma, all the way included 3.5. Now, the domain is probably, the range is probably the trickiest thing in this case. I come over here and I say, well, let's watch the range. Okay, well, the range is 0.5, 0.71, 0.92, and 1.3. And I may even go ahead and just write it that way. Range is 0.5, comma, 0.71, comma, 0.92, comma, and 1.13, comma. In interval notation, it would actually be really similar. I'm just going to write that here. Interval notation would look like this. Block 0.5, it's included, or 0.71, it is included, or not 0.92, it is included, or 1.13 is included. And this is non-continuous. Let me write that down. Continuous, yeah, I think that's right. It is non-continuous, meaning they do not connect. It does not make one single graph, and there are breaks in this information, okay? And I hope that helps out. And with that being said, have yourselves a great day. Finish out the PearDeck on your own.